All right, the unit that we are moving on to, unit 1 of your textbook actually, is all about reasoning through things and logically thinking through problems and statements, and especially at the beginning of this unit, it's not even going to seem like you're doing math. It's going to seem like you're in a language arts class. And I'm not asking you guys to write 5-paragraph essays or anything. I'm just asking you guys to write some sentences. We're going to start out with a sentence called a conditional statement. A conditional statement. So as it says in front of you, a conditional statement is a statement that can be written as an if-then statement. And then after that it says this. It says if P, then Q. Right here, if P then Q. So that might seem weird and awkward to you too, but the P means something and so does the Q. The P is what we call the hypothesis, and the Q part is the part that we call the conclusion. No, we are not in science class right now either. We really are in math class right now. So this part right here says the hypothesis comes after the word if. That's the P part. So if P, if the hypothesis is true, the conclusion comes after the word then. That's the part that we call the Q. So the Q comes after the N, the P comes after the P. So it's almost like a variable that represents not just a number, it represents the beginning of a sentence. All right. If you buy this cell phone, then you will receive 10 free ringtone downloads, excuse me. What is the hypothesis of this statement?
If you buy the cell phone?
You buy the cell phone. It's not if you buy the cell phone, it's just you buy the cell phone. All right, so this is the hypothesis. You buy this cell phone. We're going to call it P. Go ahead and label it P. These are kind of like your notes. So mark things up as we go. You buy this cell phone. We call it P. What's the conclusion? Will receive 10 free ringtone downloads. Good. This part right here is the conclusion, so we call this part Q. Sometimes it's necessary to rewrite a conditional statement so that it is in if-then form. Oftentimes you will read a conditional statement. It might not have an if, the hypothesis then the conclusion. It will just be a statement, not using the words if and then, and your job is going to be to rewrite it so that it does have an if and a then. So a person who practices putting will improve her golf game. That is not in if-then form, but you could do a rewrite of this statement so that it is in if-then form. If a person, so they rewrote it here, if-then form, if a person practices putting, then she will improve her golf game. So, a person practices putting. What's that called? Called the hypothesis. So I'm going to label it P. This is the P. She will improve her golf game. Confusing. So let me explain to you what that means. This part right here. If the hypothesis is true but the conclusion is false, it's called a false statement. So, for example, let's say that you buy a cell phone. You buy this cell phone, but you don't get the 10 free ringtone dial or the 10 free ringtones. So is that a true statement then?
No.
Oh, you bought the phone, but you didn't get what you were supposed to get. Therefore, this is called a false statement. Make sense? All right. What about, let's say that you practice putting, but you don't get better at your golf game. Then that is what kind of a statement? A false statement. But if you practice putting and your golf game gets better, then that's called a true statement. Right, Anthony? Okay, Kevin, right? All right. Your job right now is in problem number 1 right here. If you can see the stars, then it is night. What is the hypothesis?
You see the stars.
You can see the stars. Not if you can see the stars. It's you can see the stars. What is the conclusion? It is night. Good. Now, is that a true statement, you guys?
Not necessarily.
Yeah, and that's, you know what, that's not, well, right now it's not, but it's not, they're saying if you can see the stars, which we can't, so we couldn't even look outside right now to see if that's a true statement or not. But sometimes these statements you're going to write are going to seem awkward because they're not true. Well, and this would be a case. This would be one case. If you can see the stars, it is night. Can you ever see a star when it is not night?
Yes.
For example, what? Sun.
The sun.
The sun. What else? The moon. You can see the moon before it gets dark, right? Yeah.
It's not a
So
star, though.
those examples that you guys just showed me, just told me, those examples are called counterexamples. We're going to talk about those on the next page. Okay?
The moon's not a star.
Okay. It's not?
No. The moon's not a star.
The sun is a star.
The sun is a star.
I thought the moon was a star.
No, it's not.
Okay, don't tell anybody I didn't know that. Except it's on camera now, so. Okay. You can see the stars. The conclusion is it is night. Are we okay with that? We have a counterexample. What's our counterexample? You can see the sun when it's not night. Yes?
Wouldn't it be night on the other side though? So it would be night for her.
Okay, Mr. Fluff.
If x is an even number, then x is divisible by 2. Alright, what's the hypothesis? X is an even number. What's the conclusion? X is divisible by 2. Is that a true statement? If it's an even number, is it divisible by 2? Yeah, that is a true statement. You wouldn't be able to come up with a counterexample for problem number 2. So the hypothesis is x is an even number. The conclusion is it is divisible by 2. All right. Write a conditional statement from each of the following. So your job now is to look at the statements that are given there and change them so that they are in if-then form. So looking at number 3, 3 non-collinear points determine a plane. How can we change that? It's not in if-then form, but it is a conditional statement. So how do we change things around so that they are in if-then form? Help me out here, guys.
There are 3.
All right, go for it, Danny. Try it.
If there's 3 non-collinear points, then it is a plane.
Okay, that would work. I think we could probably do a little bit better job of wording it. Anybody want to try something else? How could I word that a little bit nicer?
If there are 3 I'm not even gonna try that word. Non-collinear.
By the way, what does non-collinear mean?
They're not collinear.
They're not collinear. What does collinear mean?
See, that's a word that I
in
don't.
a straight line. Okay, so non-collinear means that they are not in a straight line. So how about this? If 3 points are non-collinear, does that make sense? If 3 points are non-collinear, then what do? They determine a plane. They make a plane. So if 3 points are non-collinear, then they determine a plane. Congruent segments have equal measures. I'm not going to write every one of these out, but wording. How can I change that into an if-then statement? An if-then conditional statement. If what is true? Go ahead, Jeremiah.
If the segments are congruent, then they have equal measures.
Excellent. If segments are congruent, then they have equal measures. All right, I am going to kind of keep going here, but I want to look at number 6. You guys can do number 5 on your own time. I will give you a chance to finish this up in a little bit here. But number 6, I want to talk about number 6 because number 6 looks weird. What kind of a picture is that? Does anybody know what that thing is called? What kind of a diagram?
A weird one.
A Venn diagram?
A Venn diagram, yeah. And see how this this circle, oval I should say, this oval inside the other one, a little bit smaller. That just means that everything that is consumed in that oval is also consumed in the other oval. So does anybody want to take a crack at what's going on here?
A housefly is an insect.
What'd you say?
A housefly is an insect.
A housefly is an insect. Is an insect a housefly?
No.
No, because the insect oval is much larger. So there might be more insects that are not houseflies. But every housefly is
Insect.
an insect. Okay? So how could you write this as an if-then statement?
If it's a housefly, or if you're a housefly, or an insect.
Yeah, if it's a housefly, then it's an insect. Yeah. If it's a housefly, then it is an insect. All right, you guys can finish up 7 and 8 and any of the other ones that you didn't finish up, but I would like to flip it over to the back page. If you guys could all do that, I'll give you a chance to finish up the others in just a minute. All right. We have a conditional statement. If a figure is a square, then it has 4 right angles. Is that a true statement? If you have a figure that's a square, it has 4 right angles. Do squares have 4 right angles, you guys?
Yes.
Yeah, that's a true statement, okay, but we could write that statement backwards. In other words, put the conclusion first and put the hypothesis last, making the old conclusion the new hypothesis, and then the old hypothesis the new conclusion. And sometimes when you write it the other way, it's still true, but sometimes it's not true. And when you write it backwards, the fancy name for writing something backwards is called its converse. So if a figure is a square, then it has 4 right angles. The converse of that, in other words, that means that you have switched around the H and the C, the hypothesis and the conclusion. Now the 4 right angles part is coming first, and the square part of it is coming last. If a figure has 4 right angles, then it is a square. Do you understand what just happened there? How we just switched the hypothesis and the conclusion. Okay? Is that a true statement?
No.
If a figure has 4 right angles, then it is a square. Why is it not? A rectangle. Very nice. A rectangle is not necessarily a square. So that is not a true statement when you write it backwards. By the way, you guys just told me rectangle makes it not true. So what is a rectangle called in this case?
A contralateral.
A counterexample. Very nice. Very nice. All right. Show that each conditional statement is false by finding a counterexample. So what I would like you guys to do is put a big old box around counterexample. We're going to write a little definition here. A counterexample is an example that shows a statement. A statement is what?
False.
Is false. Very nice. An example that shows that a statement is false. You don't have to write it in a fancy way. Just give me a counterexample. Write it however you want to write it. So number 1 says, if it is noon, if it is 12 o'clock noon, then the sun is shining. Is that a true statement? If it is noon, is the sun shining? No. Today it is. Can't believe it, but it is. So give me a counterexample. Give me an example that would say that that's not necessarily true. It wasn't shining yesterday, exactly. At noon yesterday, the sun wasn't shining. What was it doing yesterday at noon?
Hiding.
It was hiding. It was hiding behind the clouds, or maybe it was raining, or maybe it was snowing, or something like that. You understand what I'm saying? So your counterexample in this case would be that it
But yesterday was out of
wasn't shining at noon yesterday.
Actually, I think it was. I left school early.
I can't remember. Was the sunshine yesterday?
I think it
don't
was.
remember, but let's pretend that it was not. Okay. If a number is divisible by 3, then it is odd. The number is odd. If it's
False.
divisible by 3, it's odd.
False.
6? Oh, 6.
That's
Really
an
just
even.
said 6. Is 6 divisible by 3?
No.
Is 6 an
Oh,
even
yeah.
number?
Yeah, it is.
I did
6
that backwards.
is divisible by 3. What is that answer?
2.
It's 2. It's a non-decimal answer, therefore it's divisible by 3. So, but is 6 odd?
No.
There's your counterexample. It wasn't a sentence. It was a problem, an example that's showing that you have a number that's not odd, but still divisible by 3. All right. Your job here is to write the converse of these statements. So I'm going to walk you through a couple of them. And this stuff, you guys get, this is where the wording sometimes gets a little sticky because sometimes what I say you might not agree with and so on. But go ahead, Danny.
4 and 5 is the same.
Yeah, 4, you know what, you're right. 4 and 5 are the same. So you can go ahead and cross out number 5. I'd forgotten about that.
What's
Number
up
4, if you drink milk, you will be strong.
Yeah, I know the answer to this one.
What is it? What is the converse of the statement? Go ahead, Danny.
If you are strong, then you drink milk.
If you are strong, then you drink milk. Doesn't matter if it's true or false. I'm not asking you that. I'm just asking you to write the converse. If you are strong. Then you drink milk. That's why you said you knew the answer.
Yeah, because I was standing right there when you were talking about that one. Thank you.
All right, this one gets a little bit debatable. If a rectangle has 4 sides that are the same length, then it is a square.
That's not even.
So,
Yes.
is that true? If a rectangle has 4 sides that are the same length, it's a square?
Yes.
Well, no, because it was never a rectangle in the first place.
It says if it is a rectangle. If a rectangle. So you have a rectangle.
And all 4 sides are equal. It's a square. Rectangles have
But it was never actually a rectangle then.
2 separate sides.
Right.
No, a
Rectangle.
square is a rectangle. A square is a rectangle. A rectangle is not a square.
Okay.
Because a square, to be a rectangle, you have to have certain characteristics. A square has every one of those characteristics. A square has more characteristics, though. For example,
I've always found the
all
squares
4
the base.
sides are equal, but that doesn't have to be true in a rectangle. So, anyway, how are we going to write this? How are we going to write this converse? If what?
It's a squirrel. A squirrel.
If a squirrel climbs a tree, a rectangle will have 4 sides the same length.
Yes.
Seems right.
If? It seems right, yeah. If what? If what?
If
You got
these-
the if down. That's really good. You guys are doing good.
If
And
this-
a
Like halfway through
square
the problem is right then.
has
If it is a
4
square.
the same.
If it is a square, what is it?
If a square
If a so when you say if it is a square, I don't know what it is. You got to be a little bit. No, and this is why this is a controversial problem. Is what is it? So you got to be specific. You got to tell me what is it. So if a
If a square is a rectangle, then it has
If a-
4 sides of the same length.
no, if
Then it
a
has
rectangle
if a rectangle is
is a square,
then it has 4 sides the same.
Stop playing with stuff. Stop
if a rectangle is a square, then what is true?
Then the 4 sides
Can you stop touching stuff?
Then what?
It has 4
Can I say it now? Can I say then it has?
No.
Yes.
It was
Yeah, you
was
can.
identified earlier in the statement. Very good. If it's a rectangle, now we know it's a rectangle. So if a rectangle is a square, then it has
4 equal
that, but you really aren't supposed to. You're supposed to try to avoid adding words that aren't already there. So it has 4 sides the same way. Your job between now and the next time that I see you is to finish this up for me.